Alright guys, welcome to another video for Algebra 2. Um, this video will also work for Algebra 1 because we're kind of working on the same skill set, a little bit more advanced in Algebra 2, but either way the basics can be covered in this one video. And in this video we're looking at graphing special functions or piecewise functions. Okay, so this is the worksheet that you guys were given, and so what I'd like to do is I'd like to work out the odds from this worksheet. So let's go ahead and start over with number 1. Okay, so here we have a piecewise function. Now, so you guys are used to working with functions like this, right? Y equals mx plus b, where you have a slope and then you have a y-intercept. These aren't any different. The only difference now is that these functions are kind of being split up into multiple parts. And I have the first part here, the second, and the third. Let me highlight them in different colors. So here's the first, and then the green, and then we have the blue. So one of the easiest ways to work these out is just to work them out as in their constituent parts. Work them out one piece at a time, right? It's kind of like when I mentioned this in class, when you buy a puzzle. When you buy a puzzle, you usually there's kind of a method to working it out. You might want to find the outer edges first, and maybe separate the different colored pieces, and then go from there. Well, in this case, I'm going to be looking at each piece, right? So I'm looking at the top one first, looking at the screen there. So my first function is f of x equals -1. Oops, equals -1. So looking at that function, I can tell right away that there is no slope. So my slope must be 0, x, and then -1, right? So my slope is 0, and then my y-intercept is -1. So I'm graphing each of these functions separately. Okay, I'm graphing each of them separately, ignoring the others. All right, so I'm going to start at my y-intercept at -1, and then I have a slope of 0, so that means it's just a horizontal line, right? Y equals -1, so it's a horizontal line. So the next thing that I want to do, that I want to pay attention to, is I want to pay attention, let me erase all this right here. The thing I want to pay attention to next is my conditions, my parameters. So f of x equals -1 if x is less than 0. So as I look at my x-axis, or my graph here, I can break it up into two parts. The part that is greater than, where the x's is greater than 0, and the part where the x's are less than 0. And here it says my function is true for all x's less than 0, which means I can essentially ignore this part because I'm only looking at the part that is less than 0 on the left side. Okay, so I can actually erase this part of my graph. So the next thing that I want to pay attention to is this inequality sign. It is less than. So since it is less than, that means it does not include the actual 0 term. So I do an open circle. Okay? And I actually might want to, I'll probably want to address that earlier next time. So let's look at that. Let's look at the next function there in green. So f of x equals 2x, and there is no, the y-intercept is 0, right? So I'm going to start off there. Now, first of all, I want to look at my inequality signs, and they are both less than or equal to, so that means that right off the bat, I know that I can draw closed circles. And I'm going to draw one at 0, and then I'm going to look over here, and there's another one at 3. So 1, 2, 3. So somewhere on this line, there's going to be a closed circle. All right. So, but let me graph my line first so I can see where it's at. So my y-intercept is 0, and then my slope is 2. So up 2 over 1, up 2 over 1, up 2 over 1. Oh, there it is right there, right on that line, right? So here's my line. Okay, here is my function. So, this can continue down this way too, but I know that I can actually ignore this part because this is a function, and this part of the graph is actually taken up by my yellow line. Now I know I said I was going to ignore it, but I can kind of, I can tell that this part of the graph here is already taken up by that red line. So I know because of that that I actually don't need this part of the function, right? So next thing that I want to do now is I want to look at my parameter, right? And it says x is greater than or equal to 0. So that means I'm looking at this part of the function because this is the part of the function where the x's are greater than 0, right? And then it also says x is less than or equal to 3. This is where this part of the graph is, right there. That's the cutoff point. So the question is, am I looking at this part of the graph or this part? And that is x is less than 3, so that means I'm looking at this part of the graph. And I can essentially ignore that half of the graph, right? So then I can erase that. And there we go. Here. Let me just draw a solid line here. Okay? So that's my second function that I have drawn right there. It is from this point, it is from this point here at the 3 to this point here at the 0. And that's because of that is because of this portion of my information, that parameter. Okay? All right. Next part, I'm looking at f of x, my last part, equals 6. All right? So again, there's no slope. But at 6, y equals 6. So 1, 2, 3, 4, 5, 6, there is a line. Right? There is a line. Now I got to look at my parameter. The function of f of x equals 6 is true when x is greater than 3. And this is a greater than, so that does not include 3. And then here's my x is 3. So for this point here, it's an open circle, and x must be greater than 3. So that means I can ignore this portion of the graph. Okay? And there we go. That's my full graph. Okay? So if you're paying attention to this, you can see that this function still obeys the vertical line test, right? Because at every vertical line, I still come in contact with only one point in this graph. There's only a couple of places where I would question that, and that would be here and here. But if I draw a vertical line, down that point, you'll notice that I still come in contact with only one point, right? And that's because this point is covered and this one is open. So it's still only one point. And it's the same thing in this area right here. I have an open circle superimposed by a closed circle. So that takes care of that one particular area. Okay? And so this is still a function. So, and because of that, because it does obey the vertical line test, I know that my domain, which is referring to all of my r's, they are all real numbers, right? But now when I'm looking at my range is a little bit different. My range is a little bit different because now I'm looking at all my y values, and I don't have all. Let's see here. Let's look at that. So as I go up my y-axis, I notice that this part of the graph there is no function. It doesn't exist. There's nothing there. So that means f of x, my y, is only true for a certain segment of my graph. So I would write it as f of x such as, okay, f of x, okay, so my graph becomes true when f of x equals, and what's this term right here? That is negative 1. Negative 1. Because I can see here that negative 1, I have a y in my function. And then after that, there's a little gap here where there's nothing. So I would do f of x is true such that f of x must equal negative 1, or it must also, and it looks like we have a range here because here it starts off again, right? And from here to here, I have a corresponding y, right? For this part of the graph, I have a corresponding y. And that keeps going up and up and up. And I have a corresponding y here still. But then as I keep going up, there's nothing more. The graph, the function stops. as far as the y-axis is concerned, there's nothing there. It's like a no man's land. And it stops at positive 6. So it ranges, so it must be greater than 0, right, because of this point right here, greater than 0, but less than 6. And remember that these are closed circles, so it is greater than or equal to 6. Here, let me I'm writing like a 2-year-old here, like my son. Well, he doesn't write f of x anything, but in any case, so my f of x must be greater than 0, greater than or equal to 0, but less than or equal to 6. Because beyond those parameters, the function does not exist as far as the y-axis is concerned. Okay, all right, let's look at the next one. Okay, this one is a little bit easier because it only has 2 parts that I'm having to pay attention to. So let's focus on the first part. So f of x equals x. So my y-intercept will be 0, and my slope is going to be 1 over 1. So 1 over 1. So let's go ahead and write that out. So the question now is, what parameters do I have? And it is, this function is true for all x's that are less than 0. So that means all the x's that are less than 0, that is referring to this part of the equation. And I can essentially ignore that part of the equation. Also keep in mind that it is a less than, so that means this is an open circle. Let me write that out here. It is an open circle here, and it is less than at that point. Okay? All right, let's do another one. F of x equals 2. So my y-intercept is at 2, and this is a greater than or equal to, so it's a closed, greater than or equal to, and then my slope is 0, so it'll go, it's a horizontal line. Okay? It's a horizontal line. So now the question is, which part of my equation am I looking at? And it says here, x, this is true for all x's greater than or equal to 0. And that corresponds to this part of the graph, because these are all the x's that refer to, that are greater than 0, and these are all the ones that are less than 0. So I can ignore that part of the function. And that does it. That's the whole thing. One thing that you should pay attention to here, and notice that anytime that you have an open circle, right, that's like a gap. That's like a gap in the bridge that needs to be closed in. And it so happens that usually now when you have an open circle like that, you're going to have a closed one superimposed to close that gap, to make it a function. And when you have that closed circle, that usually closes your domain. So then you can say for the domain, you have all real numbers. Because if I look at the x's that correspond to this function, it's basically all of them. Because this line down here goes on for eternity, infinity in a negative sense. And then this one up top goes towards positive infinity for the x's. And then the ranges, you can tell that the range is going to be a gap. Because starting at this point here, so I'm paying attention to only my y-axis, right? I'm paying it, so here, let me draw it out right here off to the side. I'll draw it in blue. So this is my y-axis, right? So my y-axis has corresponding x's all the way up until you get to 0. See, if I go down here, this corresponds with my y all the way to negative infinity, right? But then it stops right here at 0. It stops right there. And then there's a gap, right? That's this gap right here. And then it starts up again right here at 2. So then I have a 2, but then it doesn't go up, it doesn't go down, it goes horizontal like that, right? It goes horizontal. But then up here, above this point here, which is a 2, and this one's 0 right there, above that point, there's nothing. The function stops existing so far as the y-axis is concerned. So then that's why in my range, I would put f of x is true such that f of x would have to be, and this is less than 0, right? So it has to be less than 0. Or, and then I say the or because there's a gap right there, so I do not include that gap, and I don't include anything up here. But I have to include this line right here, which, or f of x must also equal 2, and only 2, nothing else. So this top one here is a range of numbers that go below 0, and this one here is a specific number at 2 because it's a horizontal line. Okay? Okay. Um, let's see, I have 2 more to do. Okay. I think what I'm going to do is I'm going to stop the video here.